All right, so always start off a problem. We're going to draw the picture. We have 3 carts. It's 2 kilogram. It's moving at 3 meters per second. Cart B is 4 kilograms, initially at rest. And cart C is moving in the opposite direction at 2 meters per second. And this is a 3 kilogram block. Okay? And they're all going to collide. A collides with B, then C collides, and all are perfectly inelastic, which means they stick together. So they're going to stick together, and they're ultimately going to move off with some velocity v here. Okay, now, because of this system, we think there's no horizontal forces. There's still gravity and normal force vertically, but there are no horizontal forces acting on the system if you combine them all, right? And so that implies that in the x direction, the impulse is 0, and that implies the change in momentum is 0. Okay, so that means what we're going to find is we're going to look at the initial momentum of the system. Now, remember when we do momentum calculations, we have to assign positive direction. So we'll say right is the positive direction, and we'll add up the momentum of every object in our system. Our system consists of all 3 objects, right? That's our system. So what's the momentum? Well, the 2 kilogram is moving at 3 meters per second to the right, which is positive. The 4 kilogram is moving at 0 meters per second, so m times v, and then m times v of this guy. The 3 kilogram block is moving at negative 2 meters per second because it's going to the left, and I said left was negative. And this is going to be 6 plus 0 minus 6, and that's going to give you 0. Now, the final momentum is, again, each of these masses, but they're all stuck together, so they're all moving with the same velocity. Right? So 2, 4, and 3, you can think of it as a single object that's 6 plus 3, 9 kilograms times some final velocity. Right? Because 2 plus 4 plus 3, right? And that has to equal 0, the initial momentum, because if the change in momentum is 0, that means that the initial momentum equals the final momentum. That means v equals 0. That means all objects come to a stop. Okay, let's calculate the total kinetic energy of the system before and after the collisions. Before the first collision, after the final collision. So let's look at the initial kinetic energy of the system. That is, you're just going to add 1/2 mv squared for every object in the system. So 1/2 times 2 times 3 squared, plus 1/2, the m of this guy is 4, and his velocity is 0. And then the m of this guy is 3, and his velocity is 2. Or speed is 2. Doesn't really matter. You don't have to put negative because it's speed only for kinetic energy. So this is going to be, just use your calculator for this. This would be 9 plus 0.5 times 3 times 4. That's going to be 15 joules. And then what's the final energy that we're going to end up with? Okay, so 9. Yeah. Well, every object has a speed of 0. Right? So they don't have any kinetic energy. So it's just going to be 0 joules of kinetic energy. Why? Because the V is 0 for all the objects, right? So we're going to start with 15 joules, and this is why we can't use working energy. We lost some kinetic energy in that collision. There. Determine the total momentum of the system at each stage of the collision. It's actually kind of a trick question. The momentum of the system is not changing. So therefore, it's going to be 0. That means before the first collision, that we said the momentum was 0. Then after the first, the momentum will be 0. And then after the second, the momentum is 0. And that's because there is no external forces that are going to cause a change in the momentum. Now, if you want to know how fast each of them individually are moving, is fine. But the total momentum is going to be 0 the entire time.